Hi, I'm Nathan Carr, and this is my AI job application tracker, a full-stack web application built for the AI assisted programming module. In this video, I'll show you how I used AI assisted programming throughout my development, demonstrate my advanced RAG implementation, walk through the code architecture, and then show the app in action. First, let me show you my AI usage documentation. As you can see, I've documented all the AI tools I've used. ChatGPT as my primary assistant, GitHub Copilot for code autocomplete, the Google Gemini API for AI features, and GitHub Codespaces as my development environment. The documentation covers 5 prompting techniques I've learned from the module. I used few-shot prompting to train the AI on what good resume bullet points should look like, prompt refinement to improve outputs through iteration, context-aware prompting when modifying existing code, debugging prompts to fix network issues, and a chain of thought prompting to design complex features like RAG before I wrote any code. Most importantly, I implemented a working RAG system as my advanced technique, something I'll demonstrate in detail in a moment. Let me show you 2 of my most effective prompts. Here is my component refactoring prompt. Split my app TSX into off panel, jobs panel, and AI panel. Rewrite prompts, types, and state lifting. Keep Firestore logic separate. This was effective because it was specific about what components I wanted and what logic should stay separate. The AI understood exactly what I needed and delivered a clean, modular architecture. Another example was my AI endpoint prompt. Write a fast API endpoint that accepts job title, job description, and CV text. Call Gemini to generate a resume summary. Use Pydantic models and error handling. Again, being specific about the framework, parameters, and requirements got me production-ready code that integrated cleanly with my existing API. These examples show how good prompting is all about being precise and contextual. Vague prompts get vague results. Now, here's the core of my project, Retrieval Augmented Generation. My RAG implementation works like this. When a user asks for job application advice, the backend retrieves relevant past application summaries using semantic embeddings. Specifically, I use Gemini's text embedding 004 model to embed both the user's query and my knowledge base. Then I calculate cosine similarity to find the most relevant examples, the retrieval step. Next, I inject those examples into the prompt for Gemini. That's the augmentation step. Finally, Gemini generates personalized advice based on the context, the generation step. This is RAG in action. It's not just a generic response. It's tailored to the user's situation using real retrieved examples. The system falls back gracefully if embeddings fail, and even auto-detects which Gemini model is available on startup. Now let me show you where the heavy lifting happens. This is my fast API backend. At the top, I configure Gemini to do something important, auto-detect which model is available. This code here, it checks all available Gemini models and prefers the latest ones, 1.5 Flash or Pro, but falls back to older versions if needed. This is robust API integration, not just a hard-coded model name. Here's my RAG implementation. I have 3 key functions. Embedded text, which uses Gemini's embedding model to convert text into vectors. Cosine similarity, which measures how similar 2 vectors are. And a top K context, which retrieves the top 3 most similar past applications. Notice the error handling. If embeddings fail, it returns static defaults. I've got 4 main AI endpoints: resume suggestions, interview questions, cover letters, and RAG advice. Let me show you the resume suggestions endpoint as an example. This endpoint gets a job title, job description, and the CV text. It calls Gemini with a structured prompt asking for JSON output. Here's where it gets interesting. I parse the JSON strictly, but I also have salvage logic. If the AI returns JSON wrapped in Markdown code blocks, I extract just the JSON object. If that fails, I fall back to sensible defaults. This is where my app never crashes on API calls. For the resource exhausted exception handling, when I hit Gemini's quota limit, instead of crashing, I got a log warning and keep using defaults. The front end is split into focus components: AI panel for the AI tools, jobs panel for job management, and auth panel for login. This modular structure makes the code maintainable. Each component is self-contained but shares data through prompts. The jobs API TS file handles all Firestore communication, keeping API logic separate from React logic. This clean separation between concerns is something I learned from AI-assisted refactoring. Initially, my app TSX file was over 500 lines, a mess. Breaking it down made everything cleaner. Now, let's see my app in action. Here's the landing page. This is a job application tracking system integrated with AI. Let me sign in. I'm using Firebase authentication. Once logged in, I can manage job applications and access AI tools for each job. Here is my job dashboard. I can see all my job applications with a summary card showing totals. There's a search bar also and status filters so I can optimize my job hunting. When I add a job, I fill in the role, company, and status. This data gets saved to Firestore. Now the AI features. This is the AI panel. Let me show you the resume suggestion tools first. I can paste in my CV and the AI analyzes it against the job description, then gives me personalized suggestions, a better summary for my profile, key skills to highlight, and specific bullet points for my cover letter. Here is the interview questions tool. It generates tailored questions, general questions about the role, technical questions specific to the job description, and behavioral questions. These aren't generic, they're specific to the job posting and my CV. RAG advice retrieves relevant examples and generates personalized advice using that context. The cover letter generator produces a tailored letter based on the job and the CV text. And finally, all AI outputs are saved in Firestore history. So when I scroll down, you can see the previous AI results from this job, including timestamps and summaries. So that's my AI job application tracker. It includes Firebase authentication and Firebase storage, a fast API backend with Gemini integration, a working RAG advanced technique, a GitHub CI pipeline with GitHub Actions, and a React frontend with clean component structure and professional UI. Thanks for watching.